If you want to get started in blockchain development, the best way is to do some coding. And as a beginner, you want to keep it simple. In this video, we're going to code a token on the Binance Smart Chain. You will have your own digital coin that live inside the blockchain. You don't need to install anything on your computer. You also don't need any prior knowledge in programming or blockchain. And you can follow no matter if you are on Windows, Linux, or Mac. If you don't know me, I'm Julian, and on Eat the Blocks, I teach blockchain development. There are so many blockchains: Bitcoin, Ethereum, Binance Smart Chain, Cardano, etc. We need to pick one. Bitcoin is too simple. We can just send simple transactions, but there are no smart contracts. Then we have many blockchains like Cardano, which will have smart contract in the future, but this is not ready yet. Then we have Ethereum. It's the first blockchain that introduced smart contracts, and for a long time it was the most active in terms of transaction volume and user, especially for decentralized finance applications. Very recently, Binance Smart Chain overtook Ethereum for DeFi applications. This was a big shock to many people in the Ethereum community. This happened because Ethereum was a victim of its success and could not scale its technology quickly enough to accommodate more users. As a result, transaction fees became really high, and this caused users to flee to Binance Smart Chain, where transaction fees are much lower. Long term, I still believe that Ethereum will prevail, but in the short term, since a lot of the activity is on Binance Smart Chain, it's a good idea to learn how to build smart contract there. So we have decided which blockchain to focus on, Binance Smart Chain, and next we need to understand how it works. There is one very important thing you need to know. The Binance Smart Chain is a copy and paste of Ethereum. The only part that is different is the consensus mechanism. On Ethereum, this is a truly decentralized blockchain where everybody can participate and be a miner. On Binance Smart Chain, miners need to be pre-approved, and there are only 21. That means that Binance Smart Chain is centralized and is not truly a blockchain. Apart from the consensus mechanism, everything else on the Binance Smart Chain is exactly like on Ethereum. So everything I will explain in this section also applies to Ethereum. Binance Smart Chain is a network of computers. Each computer runs what we call a node, which is a fancy name that just means the software of Binance Smart Chain. On Binance Smart Chain, like on Bitcoin, you can do financial transfers using the native cryptocurrency of Binance Smart Chain, the BNB token. What makes Binance Smart Chain so powerful is smart contracts. Smart contracts are little programs that run on the blockchain. These programs are unstoppable. Once you deploy them, they run forever, nobody can stop them. It's also not possible to modify their code. Smart contracts are written with a programming language called Solidity. The syntax is similar to JavaScript, but under the hood, it works very differently. Okay, so now you have a basic understanding of the Binance Smart Chain. Next, we need to understand tokens, because that's what we will code in our smart contract. In crypto, you will hear two words that are used somewhat interchangeably, but which actually mean different things. On one side, you have cryptocurrencies or coins, and on the other side, you have tokens. A cryptocurrency means a digital currency that lives on the blockchain. But so does a token. So what's the difference? A cryptocurrency is the native digital currency of a blockchain, like Bitcoin or Ether. This is hard-coded in the code of the blockchain, but a token is a digital currency that can be created dynamically on demand by anyone. This is not part of the original code of the blockchain. This lives in small programs that can be deployed at any time. These programs are the smart contracts that I mentioned in the previous section. The blockchain does not have any concept of what is a token. It just knows how to run smart contracts. The blockchain does not care that your smart contract represents a token, a decentralized exchange, or whatever else you want to code. The blockchain only sees smart contract code. That's it. Last remark for cryptocurrencies versus token. For Binance Smart Chain, it can be a bit confusing because the native cryptocurrency is called BNB tokens, but we can also create other tokens different from BNB token, and that's what we will focus on. One big problem with tokens is how to exchange them. There are many different tokens, and if each developer developed tokens in a custom way, it would be a nightmare for exchanges. That's why we created token standards. There are many token standards, and the most popular one is called ERC20. ERC20 is for fungible tokens, which mean tokens that can be exchanged against any other one, exactly like a dollar bill. In an ERC20 token, we keep track of who owns what. The identifier of an account is an address, a string of hexadecimal character. And for each address, there is an associated balance. The ERC20 standard also allows to transfer tokens from an address to another address if you are the owner of the tokens. ERC20 is for Ethereum, and for Binance Smart Chain, the equivalent standard is called BEP20, and it's exactly the same thing as ERC20 on Ethereum. Okay, so now you understand what is a token. Next, we are going to start coding our smart contract. For coding our smart contract, we will use a tool called Remix. This is an online code editor for Solidity, the programming language for smart contract on a Binance Smart Chain. It's super convenient to use. You just have to load this URL in your browser, nothing to install on your computer. So first, we're gonna make sure that we have the correct version of Solidity installed. So you go there and you make sure that we have Solidity 0.8.2. Okay, so then we're gonna go to the file editor and we're gonna create a new file that we're gonna call token.sol. So Solidity file have an extension .sol. Okay, so we're gonna open this file. Okay, so let me get rid here of this part. Okay, we have more space now. So usually we have one smart contract per Solidity file, but it's also possible to have several smart contracts in a single file. So we start our smart contract with what we call the pragma statement. So that's to indicate to Solidity which version we are using, 0.8.2, and then we declare a smart contract by using the contract keyword, then the name of the smart contract. So usually the name of the smart contract is the same as the file. This is a convention. You don't have to, but it's better to do it that way. Then we are going to define the data that is stored in our smart contract. We're going to start with the total supply, which is the total amount of tokens that will be available. So for our token, we will create all the tokens when we first create our smart contract, but it's possible to do something a little bit more advanced where new tokens can be created in the future as well. So we are going to define a variable of type integer, and we make it public. So that means we can read this value from outside of the smart contract. There is also another possibility if you put private, and this is a little bit misleading. Private variable cannot be read from outside the smart contract using the API of Ethereum. But since everything is in the blockchain and the blockchain is public, if you run your own Binance Smart Chain node and you use some security tools, you can still read the value of these variables. So don't be fooled into thinking that private variables are totally private. If you really want to read them, it's possible. Okay, so here we make it public and we call this total supply. So here you notice that I put an uppercase for the second word. That's what we call camel case. So that's a convention. You don't need to follow this, but in Solidity, that's usually what we do. And so now that I've declared my variable, I'm going to assign a value to it. So let's say that I want 10,000 token. So here I'm going to assign a value of 10,000 to this variable. Then we're going to declare another variable of type string. So a string is a string of character. So this is going to be public, and we're going to call it name, and we're going to assign it a value. So for string, you have to wrap them with a double quote, and we're going to call this my token. So that's the metadata of the token here. Then another metadata is the symbol. So the symbol, this is used by exchanges when you want to buy and sell the token. So usually it's 3-letter TKN, for example. And then we're going to define what we call the decimals. And for most tokens, the decimal is 18. And decimal defines the smallest fraction of a token that you can transfer. So here, if you put 18 as decimal, then we will need to multiply this by 10 power 18. So like double asterisk here means power in Solidity. When people say that they transfer a whole token, they actually, in this case, they're going to transfer 10 power 18. But on the wallet side, it will only show you one token. Okay, and after that, we are going to define a mapping for the balances. So a mapping is a key value store. It allows you to use a series of records. So we're going to use an address to reference each record, and it's going to map to an integer, and we're going to call this balances. That's how we're going to track the token balance for each address. So for example, for one address, it's going to be here, the address, whatever, and then it's going to map to, I don't know, 1,200, then second address, 2,500, etc. So here for these value here, we are not going to change them after we deploy the smart contract. These are the initial value and they will never change. However, for the balances mapping, it will be constantly updated. Then we're going to define a constructor. So a constructor is a piece of code that is executed only once when you deploy your smart contract. So here you use the constructor keyword. Then here between parentheses, you can pass it some data. In our case, we don't pass anything. And inside the constructor, you can have some code. In our case, we are going to send the whole supply of token to the address that deploy the smart contract. So in Solidity, the way we update a record in a mapping is with this notation, with the square bracket. And inside, we're going to reference the address. So we have a built-in variable in Solidity, which is msg.sender, and that is the address that sent the transaction. And when you deploy a smart contract, this is actually a transaction. So here, whoever deploy this token will receive all the token, total supply. So most likely this MSG sender will be the admin of a project. And after this admin will find some way to distribute the token. It can be an ICO, an IEO, an airdrop, etc. And after that, the life cycle of the token will start. Then we are going to create our first function. Function allow you to either read data from the smart contract or modify its data. So first, we're going to create a function to read the balance for any address, and we're going to call this balance of. So here you can see the function keyword, then the name of the function, then between parentheses, you pass what we call arguments. Arguments are any data you can pass to this function. And in this case, we're going to pass the address that we want to query. So here you define the type of the argument. So this is type address, and here the name of the argument. You can choose whatever name you want. And then we're going to make this function public. So that means this function can be called from outside smart contract. There are also some other functions that are private that can only be called from inside smart contract. Then we're going to make this function view. So that means this is a read-only function. And we're going to specify the return argument. We use the returns keyword with the S, and we're going to return an integer. And after, inside the body of the function, we use the return keyword. So here, this time return is without an S. Very important. A lot of people get confused here. And we reference the mapping of balances, and then we pass it the owner variable that we got as argument. And we terminate the statement by a semicolon like all statement in Solidity. All right, so our smart contract is shaping up nicely. That's a good first step. And next, we're going to do something a little bit more advanced. So in this section, we're going to create a function to transfer a token from an address to another address. So for that, we are going to create this function and call it transfer. By the way, all the name I'm using here, balance of transfer, etc. I don't just choose this name randomly, but they are required function mentioned in the BEP20 token standard. Transfer has two arguments. First, the recipient address, and then how much token we want to transfer. So here, when I say how much token we want to transfer, I'm actually talking in terms of fraction of token. So if you want to transfer 1 token here for the value, you don't pass it 1, but you pass 1 times 10 power 18, and why 18? Because this is the number of decimal that we've specified here. We're going to make this public, and it's also going to return a Boolean value. And this time it doesn't have the view keyword because this is not read-only, but it's actually going to modify data on the blockchain. And inside, we are going to use a require statement. So require statement allows you to test a logical condition, and if the condition is true, then the execution continues. Otherwise, it throws an error and the transaction is cancelled. So first, we need to make sure that the sender of the transaction has enough token in order to do this transfer. If you have, I don't know, 1,000 token, it's not possible to send 2,000 token to someone else. So for that, we're going to use the balance of function that we created before, and we're going to call it with this syntax, and between parentheses, we are going to pass the address of the sender of the transaction. So once again, this is the built-in variable MSG sender, and it needs to be superior or equal to the value that we want to transfer. And if this condition is not true, meaning the sender of the transaction doesn't have enough token, we are going to abort the transaction and send an error message, balance to low, okay, then semicolon. And if this require statement pass, we're going to continue, and we're going to update the balances mapping. We reference first the recipient. So we could do something like this: balance to equal balance to plus value, but it's a bit redundant to write this thing twice, so we can use another syntax: plus equal, and this means balance to equal balance to plus value. So this is what we call the increment operator. And then we need to decrement the balance for the sender of the transaction, so balances of MSG sender, and this time we use the decrement operator. Decrement operator means this, like this, but we can make it shorter, like this, okay. Then we are going to emit an event. So events are data package that can be emitted from a smart contract and consumed from outside the smart contract. So smart contract just emit events, but after one smart contract has emitted an event, it cannot read past event. However, wallets and any external software can listen to these events. So we declare event like this with the event keyword, and typically we define event with an uppercase letter at the beginning. Name of the event is transfer, and after, between parentheses, we're going to define a different field of the event. So the first field is an address. Index means that we can filter this event from outside the blockchain. So we can say, for example, give me all the events with the from field equal to this value. Then we want the recipient, and then we want the value, okay. And after, in the transfer function, we're going to emit an event by using the emit keyword, emit transfer. And so for the from field, this is going to be MSG sender, then the recipient is 2, and then the value, okay. And finally, we are going to return true. And here I return true because in the specification of BEP20 token, we do have to return a Boolean value. Okay, so our token is almost done, but we still need to add one piece of functionality, and it will be a little bit more complex than what we have done so far. So in this section, we're going to create a function to do delegated transfer. So with delegated transfer, it's possible for another address to spend tokens on behalf of another address. And this is very used by decentralized exchange who manipulate tokens. So instead of sending your token directly to the address of a smart contract, usually what you do is that you allow the smart contract to spend token on your behalf. And then this smart contract from inside its code will pull the token from your address to its own address. So before we start the transfer from function, we need to define a new variable. So it's going to be a mapping of address, and we're going to have a nested mapping. And it's going to be address that maps to integer, and this is going to be a public mapping, and we're going to call this allowance. So the outer address will be the owner of a token, and then for each token owner, we can have a series of nested mapping with the address of a spender, and this will map to how much the spender can spend. So here for any owner, you can have an arbitrary number of different spender ABC, and each with a different allowance. This guy can spend 10,000 on your behalf, this guy 20,000, 30,000, etc. Okay. And after that, we're going to create a function to set this allowance. And we're going to call this approve. And first, we want the address of the spender. And then how much the spender is allowed to spend on your behalf. Then this is a public function. And it's going to return a Boolean value. And so first, we reference the allowance mapping. So we reference the outer key. So that's the owner of the token. Then the spender. So that's the nested mapping here. And finally, for the value, we assign it like this. So it means this guy has the right to spend this many tokens belonging to this guy. And we're also going to emit an event here. So we define this event first, event approval. And first, we want the address of the owner, the address of the spender, and the value. Okay, and now after, we're going to emit an event, emit approval, and first the address of the owner, then of the spender, then the value. Finally, we return true. Okay, so we have our approval system in place. So the last step is to create our function to do the delegated transfer. And we're going to call this transfer from, and this is going to accept a couple of arguments. First, address from, address to. From is the owner, to is the recipient of the token, and then how much token we want to transfer. We make this public, and this is also going to return a Boolean value. At first, we need to make sure that the owner has enough token. So balance of the owner of token, it needs to be superior or equal to value. And the error message is balance too low. Oops, I just realized here it's not return true, but it's return a Boolean. Okay, typo. Then we need another require statement to check that the sender of this transaction is an approved spender for the from address. So we check this with the allowance mapping. We reference the owner of token, then the sender of the transaction, and this needs to be superior or equal to value. And the error message is allowance too low. Okay, and after we're going to update the two balances. So balances of the recipient, we increment of value, then balances of the owner of token is going to be decreased. We emit an event. So it's going to be not from MSG sender, because MSG sender is the allowed spender, but it's not the token owner. So it's the address is from, then the recipient is to, and for this amount of token, and finally we return true. Congratulations, we have finished the coding, and next we're going to deploy our smart contract on the Binance Smart Chain. First, you need to install a wallet on your computer. There are many available, but I recommend to use MetaMask, which is a Chrome extension. It was originally designed for Ethereum, but it also works for Binance Smart Chain. So you go to the Chrome Web Store, you search for MetaMask, and you install it. We are going to deploy to the testnet of Binance Smart Chain. This is a safe playground that you can use when you develop your smart contract on Binance Smart Chain. In order to deploy our smart contract, we will need some testnet BNB tokens. For that, we can use the faucet of the Binance Smart Chain testnet. You open your MetaMask extension and you copy the address of the first account and you put it here. Give me BNB token, 1 BNB. You wait a bit. Okay, so the testnet token were sent. Next, you need to configure MetaMask to connect to the testnet of Binance Smart Chain. So for this, we will need to use these parameters that you can find at this address. So let me open MetaMask and we're going to configure a new network. We're going to call this Binance Smart Chain testnet. And for the RPC URL, we're going to use that one. And for the chain ID, it's 97. Okay, so it's cut off on my screen, but just below you'll have a save button. So you click on this. Okay, so we're connected to Binance Smart Chain testnet now. And after you can see your updated balance. So MetaMask was designed for Ethereum, so that's why it shows you 1 ETH, but it's actually 1 BNB token. So next you go back to Remix and we are going to the deployment tab here. And first, we're going to select injected Web3 for the environment. So here we select the first account, connect. And here we select the first account. And so it shows you 1 Ether. So once again, Remix was originally designed for Ethereum. So it shows you 1 Ether, but it's actually 1 BNB token. So for the gas limit, you leave it unchanged. So very briefly, gas is a unit that is used to specify how much you are willing to pay for transaction fees. Whenever you send a transaction to the Binance Smart Chain, you need to pay for transaction fees. So gas is a discussion on its own. I have a full series on gas. You can check this out after if you want. And here, let's scroll down. So we select the correct contract token. Okay, we deploy this. And here you're gonna have this pop-up of MetaMask. So here it tells you how much BNB token is going to spend for the deployment. You click on confirm. You need to wait for the transaction to be mined. And here we can see that the transaction was successful. And here you can open this and you see different buttons for each function of your smart contracts. For example, we can get the balance of the main address. So let's copy here this address. Let's go to balance of. Okay, click there. And here we can see the balance here is 10 power 18, so that's 1 BNB token. And so as a test, so we can try to send some BNB token to someone else. So let me see, do we have another address available here? No. So we're just going to create another address. So I'm going to this website to generate an address. Here I click on generate. Okay, let me copy this back to Remix. So we're going to transfer to this address, and here we're going to transfer 10 cent of token. Okay, so we click on transfer. We have the pop-up. We confirm. Okay, so the transaction was sent. And so now if we check the balance of the recipient address, balance off, and we can see 10. It works. So we have successfully deployed our smart contract to the testnet of Binance Smart Chain, and I'll also show you how to interact with this smart contract. The procedure for the real network of Binance Smart Chain that we call mainnet is exactly the same, except that of course there is no faucet for the mainnet of Binance Smart Chain. You cannot get free BNB token, you have to buy them yourself at an exchange like Binance, for example. Congratulations! Now you know how to code a smart contract in Solidity, how to deploy a smart contract to the blockchain, and how a token works. Not bad for a beginner. As I said before, Binance Smart Chain is actually based on the Ethereum technology. So you can also reapply your knowledge to the whole Ethereum ecosystem as well as any blockchain based on Ethereum like Tron. If you want to continue in your blockchain journey, I have two recommendations for you. First, you can check out this video where I explain more details on how Ethereum works. And after, you can also watch this playlist where I explain in details Solidity, the programming language for smart contracts. I'll see you there.